Hello, my name is George Bryn. I am with the Tesla Scientific Foundation, a board member, and we are here today to witness the firing of a unusual Tesla coil, which is horizontal, created by Leslie Baird, who is an expert in Tesla scientific technology and has been working on this for many years. And we're going to witness something that we haven't seen in a long time, and it's probably the largest Tesla coil in private hands in the United States at the present time. Leslie Baird has been experimenting with science of electricity and magnetism as well as other scientific phenomena since childhood, most likely from her ancestral calling as descendant of Michael Faraday, the English 19th century scientist and eminent member of the Royal Society of London. Though Michael Faraday had no children, Leslie is a direct descendant of his uncle. Faraday is known for his many experimental discoveries regarding electricity and magnetism. Most important is the discovery of induction that produced the first electric motor attributed to Faraday. Leslie has studied at various institutions, including MIT, where an illness caused her withdrawal. In her younger years, Leslie completed a working atom smasher. What caused your interest in Nikola Tesla's work that led you to build 1 to 2 million volt Tesla coil?
It started when I was 6. My father brought home one of these magnetron magnets, and it set off all kinds of bells and whistles in my head. Here was an inanimate object that would take things away from you and not give them back, and you could feel it pulling, but you couldn't see how. And I knew I had to find out how.
This coil seems to be different than most that I've seen. Leslie, your Tesla coil is horizontal and not vertical like most constructed Tesla coils. Is there a reason for this particular design?
Well, I thought I could take Tesla's word for the work that he did, and I decided I wasn't going to duplicate that. It wasn't worth my time, and so I wanted to build. This is a half wavelength machine. It's a little higher frequency than the others, and it's got a lot of advantages.
How do I know? How do you explain the half wavelength? I don't understand that.
The coupling is 0.6. It's a strong coupling, and it couples the entire coil, and it ends up the voltage that goes, alternates between the two sides. This is a half wavelength. A quarter wavelength machine would have one end grounded. It's more efficient, and it allows me to study the sparks better, to direct the sparks and study the behavior. I mostly built this coil so that I could have experience with hundreds of millions of watts before I went into the billion-watt range. From what I learned on this coil, I was able to develop phased array pulse generators that get up into that range of energies. I was able to figure out how to do that.
Imagine you're still working on that.
Yeah, I have been.
Okay. What field in your scientific experiments with electricity and magnetism do you consider your main areas of expertise and interest? In the past, you have mentioned Paul Drude and his works, and how does his work relate to yours?
Paul Drude was the only person to start publishing papers on the work of Tesla. And my area of interest, anyhow, is on the properties of space. And since modern science doesn't consider space to exist, I'm probably alone in my field. Current concepts don't include space as having any properties.
So then,
so I'm working with these high fields to distort the properties of space.
What are your future aspirations and goals as such relates to physics of electricity and magnetism, or are there any areas of physics that you care to relate now?
Oh, God.
It's a general question, and
no, I don't want to talk about it.
You don't even want to talk about it. All right, that's fine. Let's, if we can, let's go to the operation of this particular Tesla coil and how it starts from the beginning and how the electricity actually gets here. If we can
First
go back
thing I have to do is to raise this little switch here. And that.
Now okay. So that prevents a.
That opens up the circuit.
there could be substantial energy left after the
Yeah.
after the
Depends on
coil
where it is in the cycle.
after the coil is charged.
Sometimes you get nothing. A lot of the times you get a bang, and
Okay.
it could be lethal.
And then the wires come back from the Tesla coil
I'll
through
go-
these.
go-
Okay, I'll follow you.
I put in a 200 amp service, so I run a substantial amount of the laboratory. These are 2 fuses that I put into this box, and the safety. If the house burns down and these fuses aren't in the box, then my laboratory had nothing to do with it. This is my power panel over here.
Let's go over to your
That
power
switches
panel.
the,
Can we go over to your
the
power
current,
panel?
Yeah,
Oh,
the
excuse me.
voltage. Let me show you, for instance, this is a, just step over around here. This, turn on this night switch, I'm not connecting this in. This is a magnetic contactor, I can find where it ends here, that, oops, okay.
I was out of. Let me get your hand down there. Go ahead.
That actually fires this solenoid, which fires this,
Okay.
which is, without burning out night switches and things. When I run it, I put that in operation. The next thing is there is a gap, a spark gap on that thing. And
Sparked out.
that travels on at 3,000
Oh,
RPM.
you're not going to fire it up, are you?
No, I'm not.
Okay.
Well, actually, before we fire the Tesla coil, it is advisable to switch cameras because this camera has a computer which may be affected by the magnetic resonance of the coil.
Okay, from this panel, the current runs into that transformer.
That's the
That
large
transformer,
transformer
yeah,
over there
that-
with
and
the
that,
large
It
insulators.
produces 40,000 volts.
What's inside that transformer? If you could mention what was inside.
I went down to the scrappers in Philadelphia and I bought 400 pounds of grain oriented silicon steel. I didn't use it all, but and 80 pounds of copper wire, and I began winding. It took me about a month. From there, that is a full wave rectifier with made of
Great.
401,000 volt diodes, all bypassed with a that machine there, right there, in plexiglass.
Right in the
Each
middle.
one of those columns is a series of diodes that'll handle 100,000 volts at 100,000 watts. And in the middle of choke coils to prevent if the high frequency from the Tesla coil should jump from the secondary to the primary coil, it would run back to this thing and blow out all those diodes. The next thing it goes is a water resistor. It has to be able to handle the power, and it has to be able to handle. It has to,
You have two water resistors there.
2 water resistors.
One has the
Series.
blue
These
water in
are
it, and the
fish
other
tanks.
one in the back.
And they have a very small amount of electrolyte in them, so that I titrated to 40,000 ohms to limit the power from this to 1 amp maximum. And from there, it goes through these PVC
But before that,
pipes.
Leslie, just 1 minute. This transformer steps up the original power from the.
takes 240 volts and steps it up to 40,000 volts.
Okay.
Wow.
And this is a set of resistors that feed the power of the meter on the power panel, tell me how many volts I got. And this is another set of resistors that tells, that's AC, this tells me the DC voltage. And from there they go into this PVC.
This PVC.
PVC pipe, and they're piped over to the bottom of the Tesla coil, where they connect the well, it's hard to say. They connect a bunch of things. They connect the spark gap.
Could you show us where the spark gap is?
Yeah, this is a safety gap to make sure that it doesn't. That if there's a voltage overlap, that'll fire before my capacitors explode. And this is a spark gap. This goes around at 3,000 RPM, and it's designed to blow out the spark soon after it's been created. And what that does is it keeps the voltage level high. That if you let it just oscillate, it'll wind down. It'll radiate away all of its power, and so you want to keep it high so that it fires again. So you keep the voltage more or less constant.
Also, behind the Tesla coil are 2 gray boxes, and what
those
are
those are standard power factor capacitors that handle the voltage, and they are
Can you point to them?
They charge up to 40,000 volts. These
Right
two, yeah. But, and that's the thing that that energy transmits to this secondary coil. Secondary coil is the smaller coil in the center, but it's large in terms of the number of turns, and it steps up to
How many
volts.
turns do you think they're in there,
I've
roughly?
forgotten the number. It's like
Warren, turn that little secondary light on. So we can
But there's a special way that you turn those wires.
I wound it by hand.
You wound it by hand,
Over
and then
a
you
period of
coated it
days.
with
Then
something.
it's sunk in orange shellac, which is important. The white shellac is a high dielectric constant. It's not as satisfactory as the orange. But
there's a possibility of
I've
marking
got
there.
3 gallons of shellac on that. It needs another coat.
Now these armatures out here are unusual. I've never seen anything like that.
They set the gap, and then, they give it a little bit of control. If I widen them too far, it starts jumping all over the place. So that's set at a nice, safe distance where it'll jump from here to here instead of everywhere.
And is that the reason you have this other insulator here, which is
This, I had a brick column here that and sparks were jumping out of the column because it was conductive and blowing holes in the back of my coil. And so I replaced the brick column with this porcelain insulator.
I noticed also that these what would you call these electrodes? These
It's
gaps.
just an electrode, I guess.
Electrode, and then they all come to a point like a lightning rod.
Most Tesla coils have a sphere or something that capacitance at the end, and it makes it more continuous. I was interested in the voltage, and I was interested in it, and I didn't want the capacitance.
Okay.
So,
Is there anything else that you might want to add about your Tesla coil that is different than, let's say, any other Tesla coil?
lots
that
of
you know
stuff. I mean, this is a whole lot of innovative ideas, over a period of years. It took me 10 years to build it and get this tuned and get it the way I want, and
When you say
evolved over
tune,
time.
what do you mean by tune?
Yeah, it has to resonate properly. Before I got it resonating, there were sparks jumping all up and down the side of the coil. When I got it resonating properly, there's none of that.
So this took a lot of work.
It takes,
a lot of time.
It's a labor of love, and it took a long time. That's the way knowledge is. You got to learn all this stuff.
That's
The only
wonderful.
way to learn about it is by
It's
doing
absolutely
it.
wonderful.
You can't learn this in school.
Can't learn it in school. You've got to actually do the experiment.
So.
Today we are going to observe your hand-built experimental Tesla coil in operation, 1 million volts. I understand at this point it could be 2 million, but you've cut it down to 1 million for some reason. Horizontal Tesla coil. Let's proceed with the demonstration.
Goes in. This goes in. Spark gap goes on.
Right corner here.
Okay. Okay. Oh. Whoa.
Come up into here.
Good God, that thing is
You
loud.
can come up into here.
Okay. Go ahead.
Malfunction on the end. Go forward.
You go up to about here.
Okay, I will. Go ahead.
Can you get
That thing is awesome.
It is
That
absolutely
freaking awesome. Anybody have a reaction here? What do you?
Powerful.
That thing is loud.
It is sparking all over the place.
God, can you imagine what Tesla did to his audiences back in the 1800s?
Smell the ozone.
Oh my God.
Is that what that is? You can.
Yeah, it's a lot louder than I knew it would be loud, but it's a lot louder than I expected it to be. Why is it loud, Leslie? Is it splitting air molecules?
Lightning makes a lot of noise.
Tesla evidently spoke in, I believe it was 1893, on some of his projects in the Franklin Institute, and they're going to celebrate that celebration again. They're also in the educational field, where they're going to have people demonstrate Tesla coils to high school students and to students that may come to the Franklin Institute. The Tesla community, as James mentioned, he would invite them to look at the site where the script is and invite their comments from the Tesla Science Foundation, and they'd be very welcome to have any comments. And I can guarantee you that you will have comments, because this is a very active group.